Hello folks, welcome back to Merrill Math. I'm Mr. Merrill, and today we're talking about absolute value equations. So your first question might be, well, what is absolute value? What does that mean? There are sort of three tiers to thinking about absolute value, three levels of understanding that students have. The first one, which many of you might be at the first level, and that is, I don't know what it is. You might be thinking that it's a complete mystery. That would be the first level. Second level is you think of everything that's in between the bars, the vertical bars, just make it positive. And for most students, that totally works. It's true. It's not false. The third level is really understanding what it means. And what it means is distance. Absolute value is a distance from zero. So how far is something from zero? That is its absolute value. So when you think about absolute value, think about distance. I don't know if you can hear stuff in the background, but if you hear people shouting, it's fine. So absolute value means distance from zero. So when we think about distances, so the distance from, here to California, or the distance from here to the moon, the distance from here to the sun, or from here to the equator, distances are always positive. So that's where that idea of, whatever's in the bars, just make it positive, comes from. But distances are sort of regarded as positive. So if we think about, the absolute value of a number is 1, that means the distance that number is from 1 is, or from 0, the distance the number is from 0 is equal to 1. So that means on the number line, we could put it here at -1, or we could put it here at +1. Those are the two numbers that satisfy that equation, or something like this. So 2n, the absolute value of 2n equals 2. Well, what that's saying is the distance from 0 that 2n is 2. So it could be here at -2, or it could be there at +2. So that's the way to think about that. So let's look at some examples of this, and we will kind of understand this a little bit more. So we treat absolute value kind of like we would a regular equation, meaning we have to do the same thing to both sides. But the first step that we want to get to, which I think is true of most of our examples, is getting the absolute value symbols by themselves. So the first thing you want to do is get these by themselves, which in this example it is. So the absolute value of 2x plus 3 is 7. Okay. So what that means is the distance this can be from 0 is 7. Just like we had up here, that could be a +7 or a -7. So what we're going to do is split this into two equations. So the first equation is exactly as it appears. 2x plus 3 is 7. The other one is this thing could be on the other side of 0, so going the other direction. That takes us to -7. So we have two equations to solve, but luckily the steps are going to be exactly the same because these parts are the same. So we've got 3 to subtract all the way across. So that gives us 2x is 7 minus 3. That's going to be a 4. We have 2x is a -10. So here x is -5 if we divide by 2. And here we're going to divide by 2, so x is 2, because 2 times 2 is 4. 2 times -5 is 10. So for absolute value equations, most of the time you're going to get two answers, because typically there are two numbers that are the same distance from 0 on the number line. The only exception to that is when you start on 0. So if you have something where the distance from 0 is 0, then you can't go one direction and the other direction because you're not going any direction. So our answers for that one, we've got 2 and -5, and that is that for that one. Let's take a look at example 2. So for this one, we've got quantity, the absolute value of 1 minus 2x is equal to 9. So we want to get the absolute value by itself, which it already is. Again, if you hear people shouting in the background, just ignore it. Sometimes there are loud people in this house. So we've got 1 minus 2x. We're going to split this into two equations. And the way that we do that is we write it exactly as it is without the bars. So 1 minus 2x is 9. Okay, like I said, you take this exactly as it appears without the bars. 1 minus 2x is 9. Then we're going to keep this side the same, 1 minus 2x. So this thing is, this step, we're always going to write whatever is in the absolute value symbol twice. One of them we put with the positive number, the other one we put with the negative number. So that is because these distances could be positive, or it could be the directions. I'm sorry, the distances are always positive. The direction we move could be in the positive direction or the negative direction. There we go. Okay, so we've got a 1 to subtract. So I've got negative 2x is negative 10, and negative 2x is 8. So that leaves us with x equals negative 4, or x equals 5. So we have two values that work for this equation. So we've got negative 4 and a positive 5. Now, let's say you get an answer and it doesn't make sense. Let's say you get something and you're like, how do I know that this is the answer? There's a trick. In algebra, you can always check your answers. So we have a 5 here. Let's plug a 5 in. So 1 minus 2 times 5, well, what is that? 1 minus 10, 2 times 5 is 10. 1 minus 10 is negative 9. The distance that negative 9 is from 0, or the absolute value of negative 9, is 9. So that works. The other one, negative 4, 1 minus 8, 1 minus negative 8. Oh, yeah. So 1 minus negative 8, because that was a negative 4. 1 minus negative 8 gives us 9, and the distance 9 is from 0 is 9. So that one works. Let's take a look at the next one. So we have the absolute value of 3x minus 3 is 8. So again, once we have the absolute value symbols by themselves, we can split it into two equations. The first one we write exactly as it appears without the bars. The next one, everything that's in the bars you bring down, but you change this sign like that. Okay, so all of our steps are going to be the same for both sides, so we can kind of batch them out here. We're going to need to add 3 to get rid of that. So that gives us 3x. 8 plus 3 is 11. And 3x, negative 8 plus 3 is negative 5. And then we divide by 3. So x is 11 thirds, or x is negative 5 thirds. So we can get fractions for these. You can get decimals. Those are all fair game. Let's take a look at the last one, and then we'll wrap up. So the last one, notice I didn't give myself a whole lot of room here. This is something you have to watch out for. So this is kind of a trick question. The absolute value of x minus 3 is equal to negative 5. So what I state here in this equation is a distance from 0, x minus 3. This distance here is a negative number. That doesn't work. So you will never have a situation where you have an absolute value on one side and a negative number on the other side. So this has no solution. So whenever you have that situation where you've got an absolute value by itself equals a negative number, there's no solution. You don't even have to do anything with it. And that is because distances can be negative. So if we understand that absolute value is the distance from 0, then this situation won't trip us up. Okay. If you have any questions, comments, points of clarification, you can leave those in the comments below. If this video helped you out, you can give it a like. If you would like to see more, then subscribe. Otherwise, thanks for watching.